Okay, the source is having frequency f1, this f2. This will send a wave. This also send a wave. This one. So at point P, let they undergo superposition. So they will arrive here. Okay, at point P. So we are intersect. So what are these? Two sources of different frequency. Are they incoherent? Yes, it will be incoherent definitely because I'm not saying F1, strictly F1, not equal to F2. So what are S1 and S2 then? They'll become incoherent sources. Okay, now the waves will arrive at point P. So let me define the superposition at x equals 0. What is y1? Y1 in fact is equal to a sine omega 1 t minus kx. What is y2? A sine omega t minus kx. Let that phase, let it be, both have same phase at that particular point. And let the superposition at point P. Where the superposition? We are taking the superposition to be at point P. Amplitude also may be equal. Let me take equal so that it will be easy for us to solve the problem. And now where the superposition at x equals 0, then I will end up with equation sin A plus sin B formula. So what is the resultant equation will be 2a cos of omega 1 check the mathematics. Is it correct? Sine of omega 1 plus omega 2 will come. Okay, further, what is omega? Omega 1, 2 pi f2. So this will become 2a cos of substituting that omega 1 2 pi f1. So I'll end up with pi agree till here. Okay, let's come. So this is the equation. Okay, you see now what is this? Is it a traveling wave? Next question comes. Where do this at point P? At point P, what happened? We'll get an equation of this kind. We'll get an equation of this kind. So is it a traveling wave? These are traveling waves. Huh? These are traveling wave. Now, what about this? Is it a traveling wave? Next question comes. Is this a traveling wave? So the wave emitted by this source will go like this. The wave emitted by this source will arrive here. They'll undergo superposition. At point P, we are taking superposition, will end up this equation. Now, what is this wave? We don't have x component, x equals 0, we have defined it. So therefore here, which one is a amplitude and which one is a signal? Because these two are signals. Signal means these are the two wave signals that are emitted. Then whenever we write equation, no, so it should be of like a sine 2 pi ft or a naught, you write it. So what is this? This part is what amplitude, no? And this is what signal frequency indicates. So like this, we do have quantities. So what about this? What about this? Because both are having a time. Now, this is F1 plus F2. That 2 pi, let me keep it here. For this, let me keep it here. Huh? For this, I need not. Okay, this one omega 2 pi, no, let it be. No, the question comes, so which one is there? This is called like a signal. I'll write in other colors. Signal frequency, this component. This component is called as amplitude. So what is this equation? This equation is y equal to a of t sine this is what like what is a of t? A of t, I wrote it to be is equal to, let it be, where a of t is what? 2a cos okay, this is the amplitude of that particular given signal. Means now, sir, how you can say this is the signal? So these two are signal frequencies, F1, F2 are. So let me write it because I'll be using often this one. F1, F2 are or frequencies of wave. Better what we say, F1, F2 are signal frequencies or frequencies of the wave. Means if I stand at point P, what do I'll get it. So the person says that the amplitude of signal varies with the time when the sources are incoherent. So very important things is what I'm going to put it now. Let me keep it these things here because here I substituted. No, yeah. So what this person will comment now? What will be the comment from the person? The person says that the amplitude of signal varies harmonically with the time. Amplitude varies means what will happen to the intensity? Intensity should vary. If intensity varies means the loudness also will vary. Amplitude or loudness. Okay, we'll have to let me put all the things here. The amplitude, the amplitude, intensity, and loudness of signal varies harmonically with the time. That is what this person will comment when the sources are incoherent. If sources are coherent, what will be the comment from the person? The amplitude, what happen, will be a function of the phase angle. And he is going to say that I'm going to hear a constant amplitude, so maxima or minima. So therefore now we have the description here. So what is the description? In standing wave, we had a situation of like this. Sine kx or cos sine omega t, cos omega t, it doesn't matter. So this is the standing wave. When sound waves undergo superposition, I think I don't have space. I'll conclude here. Y is equal to a of x sine 2 pi ft. This is what? Standing wave. When do we get a standing wave? When two waves of same speed and frequency moving opposite to each other undergo superposition. Next, when do we get the amplitude was a function of the path difference, no? So what is this? Did the interference? when two waves of same speed and frequency, no condition or direction, undergo superposition. What about beats? In beats, the amplitude will be a function of time. When two waves, frequency is same, definitely when two waves of different frequency. Undergo. So this is the core idea of the superposition of sound waves. Okay, got this one? So nothing but this is what we are discussing, no? The beats. Now let me give some other color, no? So three different colors here. Okay, got the idea, no? So when two sound waves undergo superposition, so beats will undergo or interference will take place, or will it be a standing wave in organ pipe? How a student will decide? The student will decide looking at the signals. What do you mean by signal? The two waves. These two waves is what happened. I'm calling them as signals. When two waves or signals, anything, waves or signals, both are different, are signal frequencies. Waves or signals, both are same. I'll be using that one. You can select both will indicate the same meaning. The waves or signal, that one. When two waves of same speed, same frequency, moving opposite to each other, undergo superposition, will get a standing wave. There, what will happen? The amplitude will be a function of space. A of x. What is a of x? 2a sine kx. Am I right? Then, if two waves of same frequency, coherent sources, undergo superposition, there are no condition for like a direction, undergo superposition, the amplitude will be a function of the path difference between them, or the phase difference between the waves. When two waves of different frequency, the amplitude at a given point will vary with the time. There's a condition. Okay, now, if it were interference, what will happen? Person standing here, either he is going to hear maximum sound or minimum sound, or some intensity. But what will be the intensity? Will be a constant, no? So if these two are coherent sources, what will happen to intensity at point P will be a constant, one fixed value. Say like a pretty sure like that only. Only it's going to hear a sound signal of a constant intensity or constant loudness. Suppose say these two are producing some sound, then ear open is going to hear it like this only. The intensity will be called constant at all the time. The loudness will not increase, not decrease. In case of interference, in case of beats, you look at this one. Amplitude, it varying harmonically. Varying harmonically means something increasing, decreasing, again increasing, decreasing. So if these two are incoherent, what will happen here? The intensity, the loudness here is going to vary harmonically with the time. So how it will be? La 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 la. So what's happening? The loudness, it is varying, no? This is what happens in case of beats phenomena. Are you able to understand? There's a core concept, rest all the mathematics here. So definitely what he said that varies with the time. How it varies, harmonically or any other thing, we took since harmonic waves, okay, harmonically. I can take any other time variation, but altogether varying with the time. Anybody having doubt, you can ask it, because after this I'll jump into mathematical part. There's a one best conclusion for the superposition of sound waves. Okay, fine, understood. Shall I scroll down? Okay.